Hey guys, Buildzoid here, and today we're going to be doing a rather random GPU Vcore oscilloscope video, because the reasoning for this is very simple. Some time ago, a fan of the channel sent me a bunch of dead cards, and among those dead cards was this GTX 960. And what was wrong with this GTX 960 is it basically had like memory damage, and recently I've sort of learned how to reball memory chips. And the first card I reballed was an actual working GPU because my thought process was like, well, it's really hard for me to tell if I did a good job on a card that doesn't already work, because if it doesn't work and I reball the memory chips and it still doesn't work, that doesn't tell me if I failed at reballing or if I failed at diagnosing the issue. So I took a working card, reballed that successfully. Reballed one of the memory chips on that, not everything, but like reballed one of the memory chips on it successfully, and was like, okay, so I have a method that like seems to work. And then I went and did this GTX 960 over here, and yeah, on this I reballed 2 memory chips because I was kind of too lazy to run maths, and I just kind of guessed that one of the 2 memory chips by the PCIe slot is probably the one that's like damaged. So I reballed both of them. The card now works. Previously, it wouldn't install drivers. Now it installs drivers. I don't know if it actually overclocks, but that's what we're going to maybe find out today. And yeah, so now that I have this working GTX 960, I was like trying to figure out what to do with it. And that led me to go check the hardware bot rankings for GTX 960s. And the first thing I see is this absolutely massive score from Dr. Wheeze in 3D Mark Firestrike. This is a GTX 960 at 2.1 gigahertz. This is an LN2 score. Funnily enough, it's the same model of GTX 960 as what I have here. Yeah, you can't see it, but this is actually, it might not be the same model because his PCB, wait, no. No, it is the same model. Yeah, it is, because the card just has, like, this is a thing on a lot of old 900 series cards, is the PCB is just absolutely stupid huge for no good reason. And the thing is, he blew up both of the Vcore. Like, he blew up the entire Vcore VRM, which is quite an achievement, because you don't normally see all four, like, you don't normally see multiple phases blow up at the same time. So this right here is impressive. Yeah, so this is on liquid nitrogen. Also, yeah, the power delivery on this card is kind of trash, which is why I've hooked it up to the oscilloscope, because I'm kind of wondering about how it does in terms of core voltage regulation, because evidently it doesn't do so great in terms of actually, like, providing current to a 960 core running at 2.1 gigahertz. But I'm not going to be challenging this score, because this actually just requires liquid nitrogen, and for logistical reasons, that's not really an option for me right now. Anyway, so there's this huge score in 3D Mark Firestrike, with that actually uses the same card as what I'm running here, but like, yeah, I'm not going to challenge that because don't have the cooling for it. Now there's this Firestrike Extreme score, and yeah, I'm not gonna. Oh, I think this might be. I guess MSI did like an overclocking competition. Yeah, that makes sense. This is definitely is. Let's see. Actually, no. People are using arbitrary wallpapers. So usually, wait, is it an arbitrary wallpaper or? Because usually, like, the way a lot of competitions work is that you need to use a like competition-specific desktop background. Yeah, so I can't actually tell if that's the case here, but I think there might have been, like, maybe MSI did like Rana GTX 960 overclocking event, because I can't explain why else there'd be seeming like why everybody would be running this GTX 960. There is a chance that this was actually the best GTX 960 PCB available, but I kind of doubt it. Yeah, like a lot of like usually if you want like a not top end card with a good PCB, you'd be looking at like Asus cards, because Asus likes to overbuild their GPUs for some reason. Like a lot of Asus cards will have better power delivery than the alternatives. Not always, but often. And then for 900 series, actually, there's a lot of like weirdly on paper good looking Gigabyte cards. Yeah, like there's a lot of Gigabyte cards that have like weirdly good looking power delivery. I'm not sure if it's actually good, but at least on paper it looks better than this thing. With its 2 input filtering capacitors for the entire Vcore VRM. Not that the input filtering matters that much, but I would expect to see more on most cards. But then again, 960s like don't really pull any power. And anyway, so we have some huge LN2 scores that, yeah, I'm not going to be going up against, so I keep scrolling through the list. And I see 3D Mark Vantage. Now, 3D Mark Vantage is a really funny benchmark because while it is technically a GPU benchmark, it has an absolutely ridiculously imbalanced CPU score component, right? So like 3D Mark Firestrike, and there's like online calculators that you can use to calculate your overall score from like predicted scores. 3D Mark Firestrike, if you have a massive physics score, like if you had like a 45,000 or 50,000 or higher physics score, which is the kind of thing you can do with like a 14th gen Intel CPU, you can easily go over 50K with 14th gen. You can't, like, it's not going to do that much for your overall score if your GPU is like 10,000 points or lower. But Vantage is wacky in the sense that even if your GPU is outputting like a third of, actually, yeah, like a third of your CPU score, your overall score gets like massively bumped up just because of the like score balancing algorithm for 3D Mark Vantage, which means that Vantage is one of those benchmarks that like new CPUs come out and you can like for a lot of GPUs it means completely reshuffling the rankings as like people rebench those cards with significantly faster CPUs. And you can really see that here. Like this is a, air-cooled, probably not even that good GTX 960 at the very top of the rankings, beating a card that's at like 1800 core. I wonder if there's any higher clocked cards. So we don't have any actual LN2 scores in here, but yeah, so we have this 1800 off of a single stage phase change system, right? So yeah, sub-zero cooling. Then we don't actually get a photo of the phase change hooked up to the GPU. And then actually, I wonder if, so this is getting 42,000 points. So there's only like 1,000 points difference in the GPU score here. That's interesting. I wonder if it's like LOD, because Vantage, you can also tweak the level of detail to blur all the textures into oblivion. That can bump the score up a bit. Though I would have expected 12 to be running LOD, because like 12 has a, like, well, not these days, but it used to be that you would go to some random GPU rankings and 12 would have like all the top scorers for just random GPUs. So anyway, but yeah, so this got my attention because the reason this score right here is at the very top is because this was run on a 13900 KF. So theoretically, if I manage to get my GTX 960 over here to run a higher core clock and like similar or higher memory clocks, I should be able to challenge this score because I also have a 14th gen. Like I have a 14900K, 13900KS. Like one of them is going to be able to. Okay, I'm not going to be able to run 6.1. Yeah, because this is single stage phase change on the CPU. So I'm not going to be able to hit as high clocks on the CPU, but if I get a higher GPU score, that should balance out, as long as my CPU score isn't like massively lower. Which it shouldn't be, because the difference between like 6.1 gigahertz and say 5.7, 5.8, actually for Vantage, I might be even able to run 5.9 on water cooling. Yeah, the difference between like 6.1 and 5.9 is really not that big. Or even from like 5.8. It's just, yeah, it's not really that big a deal. It's actually, I think it's like less of a difference than like 15, like say 1550 core versus 1426 core on the GPU. Now, I don't know if my card's going to do 1550, but if there's anything I can do to make it do that, I will. So anyway, so this score looks like, I could go for that. And if I'm going to be going for a score, then like if there's any core voltage regulation issues or memory voltage regulation issues on the card, I'd like to fix them ahead of time instead of, when I try to clock the card and the core clocks weirdly badly. Because that's sort of what you end up with is like if the power delivery is bad, you just can't necessarily clock the card as high as if the power delivery is good. So anyway, yeah, that's what we're doing here, is checking ahead of time if this card is going to be subject to significant cap mods or not. Yeah, I don't really want to mess with like the switching frequency on the VRM or anything because it's a crappy little four phase. At least at a glance, it's a crappy little four phase. I haven't actually checked what exact MOSFETs it uses, but it's probably not great. Um, so anyway, let's take a look at how this thing does in terms of core voltage regulation. Now we're going to run it first at stock, and we're also going to run it with an overclock. And my mouse is like weirdly laggy in the capture card. That is weird, but yeah, we're going to run it stock with maxed out power limit, and then also with like maxed core voltage, see if that even does anything, because it's an NVIDIA card, so the core voltage slider often is just a feel-good slider, as in it doesn't actually do anything. So yeah, we'll see. Anyway, we're just going to use Firestrike Graphics Test 1 for testing, because Vantage is super long, and Firestrike Graphics Test 1 is actually really heavy on the power delivery in my experience. It's basically one of, like, it's my go-to workload for testing power delivery on GPUs. Now, I think for some cards, like 3D Mark 11 or TimeSpy might actually be better, but not like heavier, but not by a significant margin. So I just default to Firestrike because that's consistently been like a good test for me. With a variety of different GPUs. As for how the oscilloscope is hooked up to the card, I just soldered a bit of coax to one of the polymer capacitors sitting behind the core, because that's just how NVIDIA cards do their Vcore filtering directly behind the core. Is you'll often have like big fat aluminum polymers there. So I soldered the coax across one of the aluminum polymers, and then there's a 50 ohm termination at the oscilloscope. Also, I have the oscilloscope bandwidth unlimited, so it's 100 megahertz bandwidth because I'm on a Rigol HDO 1104. Anyway, let's run Firestrike. Now, in terms of what I'm looking for, is I basically want this value right here to be as close to this value as possible. So, and I'm just going to reset the statistics, and honestly, this doesn't look that bad. Yeah, I was expecting worse for a random NVIDIA GPU. I was really expecting far worse. Oh wait, is the trigger actually? No, the trigger's not on. So, what we got from that run so it was averaging about 1.2 volts, which is what you'd expect for a stock Maxwell card. At least as far as I know, I've not actually run that many Maxwell GPUs. Our minimums are down to like 1.09, so 100 millivolts of undershoot, it looks like, because I suspect this is another one of those NVIDIA I think Maxwell is when NVIDIA switched over to the like V-droopless power delivery method. As in, they stopped using DC load line and switched over to using AC load line, but I'm not 100% certain about that. But even then, a lot of GPUs will have like pretty aggressive load line slopes from the get-go. Even like AMD cards, which do use I think even all the way up to like 6000 series AMD GPUs are still using like DC load line, but that load line would be pretty shallow, so you'd still have some like noticeable undershoot below the average voltage on load insertion transients. But anyway, the peak to peak is quite low. Yeah, like 200, I say quite low by NVIDIA standards, okay? Like, I've measured cards where the max peak to peak or average peak to peak are like approaching 300 millivolts or exceeding 300 millivolts. 211 is like if it's not great. Like, great would be like 100 millivolts, 150, something in that range. That's like, really nice power delivery on high-end GPUs. Like, this is actually kind of similar to a GTX 980 Ti Lightning in terms of voltage regulation. And the 980 Ti is significantly more thirsty than a 960, right? So if we take it in the context of how much power the card is pulling, this is actually kind of terrible, but I'm used to NVIDIA cards just being kind of terrible in general. So by NVIDIA GPU standards, this actually looks quite good to me. So yeah, this doesn't immediately scream like, oh yeah, this will be super, like this won't massively benefit from like cap mods at a glance, is what I'm seeing from this basically. But we're at stock, and NVIDIA GPU power delivery can get sometimes wildly worse as you start overclocking them. So we're going to just max the core voltage. I'm going to start the scope again. Oh, I should have been taking notes. Oh, well, when I do the mods, I'm going to write notes for that. So we're just going to... Wait, what? I said max the core volt. Are you kidding me? Why are NVIDIA cards so cursed? Okay, fine. We're just going to raise the core clock. Speaking of which, what is the core clock? So at plus... Oh, I hate offsets. Anyway, so we're already at 1525, which is really high. Yeah, and we're also going to bump the memory clock. I don't even know what the power limit on this thing is. So this is Samsung memory, so I'm assuming 2 gigahertz shouldn't be too difficult, right? Like, I did reball the memory chips, so, you know, that might be counterproductive to the, like, oh, it should do 2 gigahertz thing, but, yeah, so I have a bit of an overclock on there, and let's see if it'll run Firestrike. And also, if it does run, what kind of voltage regulation we're getting. Oh, actually, it doesn't. I need to reset the statistics once the card is actually under load. Because otherwise we'll have, like, idle measurements there. Okay, so... Really didn't change much. Like, yeah, there's a bit more peak to peak, but... Yeah, this is really not some, like, massive increase. It might also be just power throttling the entire time. I have no idea what the power limit on this thing is. So, yeah, really not much of a change. I mean, peak to peak went from max peak to peak went from like 211 to 236. Average went to 212 from like 190-ish. Minimum didn't really change. Average voltage didn't change at all. So that's kind of that. In terms of the clocks, it was running 1525 throughout the entire benchmark, so it doesn't, like, at least GPU-Z isn't reporting any power throttling. Apparently the power consumption was about 123 watts. And do we have a percent TDP? Max 95. Yeah, so that's not a problem, right? Like max TDP percentage is 95%. So there might be like very brief instances of power throttling, because you have to keep in mind that your monitoring software often is significantly slower than the power management circuitry on the card, right? I think GPU-Z right now is on a refresh rate of what did I just press? No. Go away. Yeah, so what's our... Yeah, we're on a 1 second logging interval. And the thing is, like, if you crank your refresh rate for the sensors through the roof, like all the way down to 0.1 seconds, it'll actually have relatively significant overhead in terms of, like, you'll start seeing performance issues. So that's, like, you can't just crank the logging software through the roof and be like, oh yeah, this is a great idea. I'm like, yeah, you get more accurate measurements at the cost of performance. So yeah, at 1 second polling interval, we're really, really slow compared to how quickly the power management on NVIDIA cards can go. I think Maxwell was already 1,000 power adjustments per second. But at the same time, on the oscilloscope, we're not seeing any big, like, obvious steps in the core voltage like you would see on, well, like you would expect to see if the card was actually bouncing off of the power limit. So yeah, I guess we're not really power throttling very much at all right now, which is good news. Also, I gotta say, I'm kind of surprised that 1525 on the core just kind of ran. I don't think I have many well, admittedly, I have one GTX 960, so I don't know, how consistent GTX 960s are in terms of core clocks, but I have a bunch of 980 Ti's, and most of those struggle to go over 1500. So, yeah. Also, I would love to know why Afterburner won't let me change the core voltage. Go away, GPU-Z. I have it unlocked. Standard MSI. Okay, let's try extended MSI. Still doesn't work. Why? Oh, well, that's, like, not really a problem, because I'll just hard mod the card in the end. But, yeah, I was kind of hoping that we'd see what happens to the voltage regulation if we increase the if we increase the voltage. Though, I think we're kind of close to the power limit, so it would actually probably just bounce off of the power limit if I raise the core voltage. Okay, let's try 1543. No, not extreme. That'll be an absolute slideshow on a card like this. Oh, I didn't reset the statistics very quickly enough. And it's really not changing, which you wouldn't, which is what you'd expect when you're raising the core clock. Like, we went from, what, 1525 to 1543? Also, I think I'm seeing, yeah, I'm definitely seeing artifacts. They're very, very brief, but there's definitely, yeah, there's some, like, red dots showing up, which is interesting. Would have expected something more violent in terms of artifacts, but oh well. Max power is still 95%. Yeah, so we're not bouncing off of the power limit. That's nice. Okay, so we'll try 232. I'm assuming it's just going to crash at this point. Or it's going to be a mess. So this is already, like, a pretty good sign, I'd say. That, like, I'm able to run Firestrike GT1 at 15, like, at over 1500. Now, okay, yeah, that just insta-crashed. But the thing is, because for Vantage, like, Vantage is way longer, so it's not actually going to hit as high clocks, because thermals are going to become a problem for Vantage, whereas they really kind of aren't for Firestrike, because Firestrike is so short. That's part of why I like it so much. It's like, it is heavy, but it's not long, so you don't run into that, because funnily enough, Vantage is not actually that heavy. It's just that you need to survive, like, what is it? I think over 4 minutes of actual, like, 3D load. Whereas with Firestrike, it's like, I think the first test is like 45 seconds, and the second test is also like 45 seconds. It's like half the runtime, right? So if you don't have a ton of cooling, Firestrike can often be less of a problem than Vantage. So yeah, if, like, Firestrike is, but if Firestrike is going over 1500, then Vantage should be able to run around 1500-ish. Okay, so we'll back the core clock down a bit, and then let's see, I don't know, plus 600 on the memory. Let's go straight to plus 639. I was really expecting this to be a lot like a reference 980 Ti. Admitted, the one issue is that all the reference 980 Ti's I have suffered VRM failures before I measured them, as in, like, Vcore power stage is blowing up. So I'm not sure, and I kind of suspect when the Vcore VRM dies, it might trash the capacitors. Because you often get, like, a short circuit from 12 volts to the output, and polymer capacitor, like, one of the few, one of the easiest ways to destroy a capacitor is to overvolt it, right? Like, if you have a 2.5 volt capacitor and you apply 5 volts to it, it's for long enough, it'll be very dead. And actually, you probably won't need to take that much time to do that. And the thing is, the output filter on reference 980 Ti's is all like SMD polymers, and I think they're either like 2 volts or 2.5 volts. So if during the short circuit the core voltage, like the voltage on the output of the Vcore VRM gets high enough, those capacitors might be pretty dead. I've not bothered to like desolder them and check like what condition they're in, because that's way too much effort. But I don't actually know how I would check what condition. Like, you can measure the capacitance, but one of the problems with polymer capacitors is like, even if you like overheat them, their capacitance won't necessarily drop, but their like ESR and ESL will get significantly worse. So they get they get significantly worse at like being good capacitors. But they still have a lot of capacitance. So you have this sort of like weird scenario where it's like, if you just check them for capacitance, it's like it won't necessarily tell you if the capacitor is actually trashed or not, which is kind of annoying. Technically, Firestrike GT2 is better for checking memory stability than Firestrike GT1. So what I'm doing right now, where I'm like cranking the memory clock and then running Firestrike GT1, is not actually a very effective way of checking memory stability. We are now seeing like 240 millivolts peak to peak, but I mean the minimums, yeah, it's still about 1.09. And yeah, it really hasn't changed. We got a 251 on the max peak to peak, so yeah, like I've seen significantly worse. Mainly on the like repaired GTX 980 Ti's, where like I think one of them was at like 450 millivolts. Just like the word, like I was honestly surprised that the thing ran. Um. Anyway, so yeah, this is like surprisingly decent. I was really expecting like, well, actually I don't know what I was expecting, but I wasn't expecting like 200-ish millivolt, like, well, 100 millivolts of like undershoot, because that's really not that bad. Um, like I wouldn't have been surprised if I saw 150, which I guess that means I would have been like not surprised if the peak to peak hit 300 millivolts, which yeah, that's true. I wouldn't be surprised if it had hit 300 millivolts. Um, anyway, so that's kind of it for this video, which ended up being unnecessarily long. But yeah, ultimately I've decided I am gonna still try to cap mod the card. And I'm gonna like track the improvement from like before and after. So I'm gonna run like more formal tests well, by more formal tests, I mean I'm gonna run Firestrike 3 times, write down the results if there's not too much difference between, like, do multiple runs so that I have more samples, and then that's kind of it. It's the only difference that's gonna change. Also, I'm gonna record the results. And I'm also going to check the memory power delivery, because I have run into, like, that's been a thing that I've run into with multiple NVIDIA cards, where their actually memory power delivery is quite noisy. And I think the reason why is, like, NVIDIA seems to be using a significant chunk of their memory voltage, like the memory power delivery, to power the actual memory controller itself. Whereas, like, say, AMD GPUs, like, yes, the physical interface that talks to the memory chips, that still needs to get powered by the same voltage that the memory chips get their power from, because that's the voltage that they use to talk to each other. But then the actual like control logic for the physical interface on the AMD cards, that has a separate power rail as far as I know. Which means that like on AMD cards, the memory power draw is actually significantly lower than NVIDIA cards. And another interesting thing is like some NVIDIA cards will actually use the memory power, like they'll use the memory voltage to then, well, they'll run the memory voltage into like a linear regulator to generate the PEX voltage. On some cards. I don't know if this one does that, but like I have a GTX 570 and there's a linear regulator that creates the PEX rail from memory voltage. So, like, and technically linear regulators have some ability to reject noise that's coming into them, but like, yeah, if the, voltage regulation coming into it, like if the voltage coming into the regulator is cleaner to begin with, you can just you can improve the power delivery of the PEX rail by accident, basically. So, and the reason I bring that up is I've had a few scenarios with NVIDIA GPUs where like I measure the memory rail, or actually before I had the oscilloscopes, I wouldn't even check the memory rail. I would just slap capacitors on the memory power delivery, and then it's like, oh, now the memory clock's like a lot better. Um, I'm not sure that this is that we're going to be seeing this here because like doing over 2 GHz is, as far as I know, is pretty high for Samsung GDDR5, but don't have a ton of experience with NVIDIA GPUs, so I'm not sure. Um, well, don't have a ton of experience with Maxwell NVIDIA GPUs specifically, so I'm not sure. But yeah, I am interested to try. Um, and yeah, so that's it for the video. And I guess in the future we might I might also make a video of actually like trying to take down the 3D Mark Vantage top score, which will mostly be CPU overclocking, I think, right? Because like that's like I need to match on the GPU side of things. It looks like I have a GPU advantage. There is a very real possibility that I don't know how to set up my NVIDIA drivers. Like again, I don't bench NVIDIA GPUs that much, so it's a semi-regular occurrence that when I try to take down, try to get some NVIDIA top score, I very quickly find out that like my score is way lower than it should be relative to the clocks that I'm running because I don't know how to set up NVIDIA cards. Um, but, or yeah, like, and when I say I don't know how to set up NVIDIA cards, like a lot of the things that you do to get benchmarks to spit out higher score include destroying the image quality, right? So this isn't really something that you would do for actual like gaming applications. This is literally just like, yeah, if you set the level of detail through the sky high, all the textures disappear and then your frame rate goes up. That kind of thing. And for some benchmarks, there's like optimal LOD values, and I don't know what they are, to be completely honest. So yeah, we'll see how that goes. But I do seem to have a clock speed advantage. So on the GPU, so then it's just like getting close enough on the CPU score, and I should be good. Um, I might also try Firestrike. Actually, you know what? Let's just do a full run. I'm gonna quickly lower the memory clock back down to something that is stable, and we're just going to do a full run of Firestrike just to see what that looks like, because I do kind of wonder. GPU-Z, could you, yes. Well, actually, we don't need monitoring at this point, so we're just going to do a quick full run. Because I'm kind of wondering, yeah, I'm just wondering, what kind of score this spits out. Also, I think the 14900K is at stock right now. Actually, no, it isn't. I think it's slightly underclocked because there was something I was testing on this system. Yeah, I think it's slightly underclocked. So if the physics score looks low, that's why. Wait, do I have system info turned on or off? I think I have it turned off, which is an issue because if you have system info running, it's pulling a bunch of sensors and there's a bit of overhead from that. So turning off system info, it slightly increases your score. And the reason I bring that up is if you're pretesting with system info turned off, you might be like, oh, my scores look good. And it's like, yeah, that's just because you're not running system info. And then when you want to actually submit, scores, you need to have the system info running. And so when you turn and then you turn it on and it's like, oh, my scores are down 1%. Which if you're competing for, actual rankings, being down 1% is kind of a problem. Actually, I think the worst case scenario I've seen with system info was -3% or something, like a pretty big chunk of the score just disappearing to system info, but that got fixed. I think that was a specific combination of some specific I think it was either a specific CPU or GPU and a specific version of system info that really hated each other. And so, yeah, in that scenario, system info was really, really bad for the score. But you can't, like, the reason you can't turn system info off is because it prevents people from, like, cheating things. And so you do have to run with it to post on, like, scores into rankings. And now let's check the... wait. Yeah, let's check the hardware bot rankings to see how that compares. So obviously this was Firestrike. And I'm not running any, like, software tweaks right now. Wait, is that a top 20? Is it? Almost. Yeah, almost. That's a top 25. Oops, wait. I didn't show the rankings. Sorry, like I was focused on like pulling up the hardware bot rankings and forgot to switch the scenes in OBS. So anyway, but yeah, so here we have 3D Mark Firestrike on the 960. My score was 8418, and then yeah, so that puts me at like top 25. I'm not actually gonna post this score right now because it's like super trash. Like, you know, like I've done the absolute bare minimum. I'm not posting this. Now, Spit 05, man, why, with random string of numbers, also posted a score. I'm assuming, yeah, that was also on the 13900 KF. So I'm kind of wondering, okay, so his physics score is bad? How's it? His GPU score, like, absolutely crushes mine. He does have NVIDIA, yeah, he has Profile Inspector on his desktop, so... Actually, I bet if we just open the verification link, it's going to tell us that his LOD is all... Yep. Yeah. So this is... So if you're going for official 3D Mark rankings, level of detail isn't, like, legal, but for hardware bot rankings, it is. And that's just because, like, the hardware bot score rankings are older than 3D Mark's ability to 3D Mark's ability to detect level of detail adjustment. So, for the sake of making it like, because there's like a bunch of old scores that basically would be like ridiculously hard to beat if you weren't allowed to modify your LOD on new versions of 3D Mark. So instead of like trashing the database, yeah, you just have like this rule split. And also it doesn't apply to all benchmarks. It's like old 3D Marks, you can do a bunch of tweaks that you can't do for like, say, TimeSpy. Like in TimeSpy, you can't do LOD because TimeSpy had LOD detection for a very, very long time. Anyway, so yeah, like his GPU score is like way higher than my physics score for a 13th gen is terrible. He disabled all his E-cores for like, yeah, he disabled everything on the CPU for some reason. Wait, is it for the combined score? Because this is like the combined test in Firestrike is weird. Is the best way to put it. Nah, his combined is actually, yeah, his combined is like not good. Like considering the clocks he's running on that CPU, his combined really isn't good. I am very confused. That GPU score, though, is massive. Wait, I wonder if the E-cores break the GPUs. I wonder... I mean, I could just process less so that, if that's the issue. Okay, so this definitely requires more testing. It could just be LOD, because LOD... I think can add something in the range of like 5 to 7%, so... Then again, I'm at higher clocks. I should be doing better than I am. Oh, wait, no, I might be wait, am I... Wait, if I pull up GPU Z, what core clock does it say that I'm at? 1405. Oh. So I don't have a core clock advantage. I hate the boost algorithm. I really do. So the issue, 1416. His card is probably running, because mine right now runs what, 1525, something like, no, 1543, right? So his card, if mine at like, mine reports that it's at like 1410 or 1405, and it runs like 1543. So his card is reporting 1410, 1416. Yeah, 1543. So he has to be running like 1550 under load. Yeah, because the boost algorithm is freaking obnoxious. Yeah, and my boost is reported as 1468. So yeah, he's all the way above like 1550. This is one thing that just frustrates me to no end with like a lot of modern hardware is when you have clock readouts that like don't tell you anything. Right? Because like this 1405 megahertz, what does that even mean? The card doesn't run at 1405, it runs at like 1543. Like what is this number for? So yeah. I mean, yeah, so probably most of it is just LOD. So I'm probably not that badly behind on like software tweaks. Um Anyway, wrong mouse. Yeah, and that's like a actually that's a solid, yeah, that's like 35 points for that. I don't think that'll actually do anything for my own points, but I mean, if I can match or get close to that GPU score, I like his physics score is really low, so I don't know. Actually, isn't his... No, the top GPU score was like 11K, wasn't it? Yeah, it's 11K. That's insane. Well, the card is at like 2 gigahertz, like 2.1 gigahertz, so makes sense. Anyway, this video just got way longer than it needed to be, but yeah, so that's it. I've got a GTX 960 to play with now. And I will play with it, because like the nice thing with like low-end like cards like this, especially if they've already failed once, is like I don't feel too bad if I accidentally break them again, right? Um, so yeah, anyway, hopefully you've found this somewhat interesting, if not particularly useful, and that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, which is how like the oscilloscope and the soldering equipment and like kind of everything gets funded. So if you check that out, it would be much appreciated. There's also the AHOC Teespring store where you can pick up shirts, posters, hoodies, you know, the usual YouTuber merch. And I've also got a Bandcamp. There's a link to that down in the description below as well. And yeah, that's it for the video. So thank you for watching and goodbye.